Hello everyone. Sorry. Hello everyone. A little bit clipping there. We are going to start a little. We are going to start a little bit. So, please wait. Please slightly wait a little bit. Of yeah, a little bit of me here. I'm setting up a little bit, and after that we can move on. So that's all. Thank you. Okay, so I guess we can sort of start. Let me look here on my some find another setting. Oh, okay. So apparently, uh, this one actually works. You want to see why? Here, if you see for my temporary, it's going to be slightly like this, right? So if I choose the thumbnail, no, if I choose here, oh, so it looks like we are a little bit slight off here. Okay, that finally works after it being so broken. Yeah, it works. It works. What a surprise! Because seriously, it didn't work perfectly fine a few days ago. It broke things. I'm just able only to use like this. So yeah, you see, boy. Okay, so it looks like I can move a little bit here. Alright, so around T minus 33 minutes. Okay, and usually it will begin at T minus 20 minutes. So I guess, okay, I guess we are relieved that everything is fine here. Unfortunately, fortunately, I think, fortunately, maybe the plugin creator site actually already fixed it. So yeah, okay. And anyways, introduction right now. So good morning everybody. I'm Dennis Suguwa, your host for today's launch commentary. I mean, obviously not the real launch commentary. If you want the real launch commentary, you might as well just go to Blue Origin, right? But that's not the point, because it's going to be boring if you just see only just one person here. I mean, there's already a bunch of people already going to live, and also including I mean, at least from what I can say from one of my friend of channel, Cat Blocksworthy. Apparently she's not live today. Yeah, maybe maybe something else happening. I mean, it's just like me. Some maybe she has something to do with her job, or maybe whatever. Just like me, just going, just became a university student. Of course, I sometimes a bit tough and what there. I'm not able to attend for the launch, but fortunately it's early morning here in Sarawak right now. It's right now around 3:26 29 a.m. here, so pretty early morning, so it's good finally. Okay, so yeah, unfortunately Kate Bloxworthy, she's not live, but out of my friends of channel apparently live too. Maybe let's say for example, I think Ross, yeah, Ross Space goes live. Also can consider Space Affairs also live, and yeah, and also a little bit, of, I can say maybe I can say like some occasional visitors here and there, and particularly not of these the Dead Space doggy guy apparently also live. But yeah, but I'm also live for today, for this morning. So yeah, today we are going to witness the launch of the Blue Origin's New Glenn rocket here. Okay, it's basically half Metalox rocket and also half Hydrolox rocket here. You know, I'm going to explain a little bit what does that propellant combination means in few moments, and yeah, and also let's just say if I don't have any night class last night, maybe I can be a little bit comprehensible. So, but yeah, I don't have properly enough sleep. So if you see me stuttering or jumbling whatever I'm saying right now, you know why. But I'll give my best for this morning. So let's try. Okay, and let's see what would be on our list. I think the most important thing is that we also have the live, not really live, but you can say almost live there. So why not we go a little bit mission about what this is actually supposed to be. Let's go here on the mission. Let's see. Yeah, it froze because I didn't focus it. Let's go here. Let's display. Okay, is it working? I'm not sure if it work. Oh yeah. Okay, it works. So this one is from the Rocket Labs itself. Regarding this mission for today, the ESCAPADE mission, yeah, because you need to know that you need to know that Rocket Lab did actually build it for UC Berkeley, the University of California, Berkeley, and also for NASA here, specifically for the Photon satellite bus design here, and also the construction, some manufacturing here and there. So that's why Rocket Lab did have their own mission patch here, as you can see. Okay, and you already know how Rocket Lab's design actually goes. It can be a little bit slightly flatty design there, flat and minimal design, pretty typical for corporate. But you can see here, this is Rocket Lab's mission patch. Okay. And yeah, ESCAPADE actually stands for Escape and Plasma Acceleration and Dynamic Explodes. So that's ESCAPADE. Okay, and this is how it looks like illustrationally. Okay, and yeah, it says mission at a glance, but I'm not going to mention too much. You know, this is a there's two NASA's ESCAPADE spacecraft here. What actually officially it's actually called as A and B, but it's also affectionately called as blue and gold actually. Yeah, so that's why. If I remember, actually, the blue and gold, it has some origin on, I don't know, if I remember, something to do with whatever. I'm not going to try to attempt like I know what I'm saying here. Why the lore, the method, the lore behind the name itself. Yeah, I'm not going to pretend to know that because I do read it, but at a glance. So let's not assume that. Okay, and you already know that mission partners here. UC Berkeley is the principal investigator, and NASA itself is actually behind the real mission of this itself. And yes, ESCAPADE, it says here that is part of the NASA small innovative missions for planetary exploration SIMPLEx program there. So that's it. Yeah, usually back then it does have mission calls the Explorers mission, something like that, but now it's mostly in the SIMPLEx mission as the focus as the spacecraft got smaller and cheaper to build. So rather than trying to build massive one big massive hundreds if not billion of dollars there, might as well you just build the small one. You just package it a little bit here and there, and then and you're still able to accomplish the same amount of mission achievement without all of that huge complexity. So that's why it's actually being used. And for the and yeah, it says here it originally plans to launch on if I remember, it's not 9 November, it's originally 7, something like that, or 9 here, but again the mission got delayed, and also especially supposedly it also should have been launched yesterday, but pretty much high solar wind concern there can pretty much disrupt the spacecraft, and also the rocket operation there really can mess up with the navigation system and also the power supply system inside there, because you need to know, unlike us being on Earth basically being protected by the by our magnetosphere, yeah, going to this go into the space directly like that, it's going to hugely disrupt the spacecraft operation to the point it may be rendered unoperational if it got into the spacecraft itself. I mean, it's a bit irony, isn't it? Right? Because the mission itself, this mission, ESCAPADE mission, it's actually also about researching how Mars magnetosphere actually disappears due to the one of the theories about is that Mars actually originally got its own atmosphere, but however, because of, can say like, I don't actually 100% can pretty much know about this, but one of it is that because Mars got bombarded so much with the solar wind to the point it literally strips the Mars magnetosphere, and eventually Mars losing its most of its own atmosphere, especially the ionosphere part. So that's why that's I said it's a bit irony why how the mission got delayed another day. But however, as long as it looks pretty good, I do hope so. And the total mission duration, it's stated here, is 43 months. So let's say if it launched today, it should be arriving around almost 4 years. Wow. Oh, basically around 3 years and 6 months, if I'm correct. Yeah, 3 years and 6 months basically by now, by the time it actually arrived, 2028. Yeah, so 2020, it's the the mission will actually still ongoing until May 2029. By then I'm not pretty sure if I still can stream around that time, but let's hope for the best. Because I really do want to cover a lot. And yeah, space program is also going to cover lots of things. That's why yeah. And the mission itself really stated that it actually investigate Mars hybrid magnetosphere. That's why. So this is a mission overview, and yeah, it does actually designed and built by Rocket Labs, and some of the components necessary for this were uh, were partly contributed both by the UC Berkeley, because they also they are also actually responsible pitching that idea to NASA as well. So NASA is pretty important, and also NASA as well. NASA did also provide some of their important component inside there, so that's fine. And yeah, usually it will orbit around red planet, but if I remember, it's actually separated by two different orbits. If I remember, the blue one, the blue spacecraft will actually orbiting around 10,000 kilometers higher, uh, highest point altitude of the Mars, while the gold itself will orbiting around the highest point altitude of 7,000 kilometers around the Mars itself. But in terms of the lowest point of the Mars itself, there's actually how do I say it? Definition. It's called every perigee. No, every G, something like that. Perigee, perigee. Yeah, like that. If I remember correctly, perigee is actually stands for the highest point of the highest point altitude of from the Mars, while the perigee it's actually the lowest altitude point from the Mars. But despite that, it's going for the lowest point of altitude of the Mars itself, it will be placed at similar altitude, 180 kilometers. Yeah, that's basically how. I mean, usually if you try to use this on Earth, it's going to deorbit pretty fast. But since Mars mostly being stripped out of its atmosphere, so how even placing at lowest point of 180 kilometers like that, it's not going to be a problem, and still can be ongoing for years to come, unlike us here, if you try to launch it from the Earth, of course, because we still have the ionospheric area there. And yeah, it's going they are also going to go there to understand the structure, composition, variability, and dynamics of Mars unique hybrid magnetosphere. And also they want to see how the solar wind actually can really strips the atmosphere away from Mars, and they want to understand better about the climate, how it changed over the time, and also why Mars no longer cannot support liquid water on its surface. I mean, if you do know some of the research here and there, you know, there's actually some interesting mission for the whole of it. Yeah, I'm not going to pretend I know about it, but if I remember, there is like frozen methane, frozen water inside Mars like that. Yeah, I mean, it's pretty interesting, right? Especially the hydroxyl group area, you know. So that's very very important. And yes, this mission would be the first time mission ever that such more than one spacecraft science missions will be heading to Mars. I mean, if you no, it's more like, how do I say, it's more like the first time that there's two spacecraft mission will ongoing at the same time. It's not like going one by one where you have like orbiter and then land, and then later you just separate lander and then it will try to land to the Mars. No, it's like once it goes to the Mars, the mission starts literally right there. It's not going to be like, oh, okay, we are going to wait for another spacecraft. Boop, okay, here we go. Let's go. Good luck, GG. Good luck, GG to the Mars. Hopefully you didn't crash. I like that. No. It's going to start right away after it reaches the Mars, already separate by altitude. That's it. It starts right away. so that's basically the NASA's ESCAPADE mission. And yeah, this was actually built and tested at the Rocket Lab's Space Systems facility in Long Beach, California, in US, of course. So here you can see what they are testing here and there. Okay, and also it installed some of the propulsion deck and also solar array and whatnot. Okay, we are not going to be too long here. And yes, it says there here, according to the Rocket Lab press kit here, it says it will take 23 months journey for to Mars here on boarding the Blue Origin's New Glenn rocket here. You know, as soon as it's launched, it would actually park itself to the Lagrange. If I remember the Lagrange point, the L2 point from Sun to Earth, like that. It's going to go there a little bit for almost 2 years there, around specifically 1 year and 11 months before finally it would head to the Mars. And it says here that the total primary mission duration would be 43 months, which also includes the 12-month Earth-centered orbit and 9 months of phasing orbit. So yeah, that's why I said it's going to be by the time this mission properly completed. Let's say, assuming there is no extension, it will be May 2020. Yeah, it's going to be a May 2029. So yeah, that's pretty interesting. And it says the primary prime science mission would mission duration would be 11 months, aka almost a year, like that. So yeah, you can see here and there. Interesting. All of these were actually based on the Photon satellite bus here. Okay, so you can see. Okay, there's solar panel, star tracker. Okay, satellite radios, and also reaction wheel. Yeah, I mean, if you play even slightly of Kerbal Space Program, you know what reaction wheels actually stands for. That one is actually sort of like gyro, you know, like a pretty advanced gyroscope that actually can that has three directional of freedom with 6 degrees of freedom angle, something like that. Yeah, if I remember, that's what their reaction wheels basically is. And also the propellant tanks, and also reaction control systems. And yeah, this one is propellant tanks, and then reaction control systems. Here you can see this one is the thruster itself, because it's not really powerful. That's why it's called as thruster. It's like a mini propulsion system there. And you can see this is the trajectory view, and that's why I said it will be placed around the Lagrange point here. Okay, before finally inserting itself to the Mars orbit at some point. So yeah, pretty cool. Okay, Liberation loitering orbit will be 12 months, aka a year, 1 year. So that's it. You can see. Yeah, and also it does have some of the design here. You can see this one is the magnetometer, the EMAC here, and also the multi-needle Langmuir probe, which actually MNLP, M actually really small letters there. Okay, and I think if you even see even slightly like Voyager mission. This is actually the magnetometer pole there. I mean, it's pretty interesting, right? I like the design actually. Okay, and also there's some medium gain antenna. I don't remember what kind of band here. If I remember, it's S band like that, S or X band, something like that. I'm not going to pretend to 100% know which what kind of antenna it uses like that. I mean, if I remember, there's actually K band, X band, and S band, something like that. I mean that. I mean, if you even hear what I'm saying, I because it sounds rhyme, but otherwise I don't want to 100% knows what is it. But there's high gain antenna, pretty big dishes there, but still pretty compact, and also medium gain antenna. Um, Basically, let's just say around how many few times smaller than high gain antenna. Maybe I think 8, 9, 10, 9 times smaller, and then low gain antenna even smaller than medium gain, but maybe around 2 times like that. Okay, and also there's star tracker, because this is very important to track, to provide, to basically act sort of like GPSs for this satellite, because remember, it's not like being on Earth. Okay, you need to navigate around the space, so that's why star tracker is pretty important here and there. It's just it's basically just on the left side of the low and medium gain antenna part there. Okay, and also there's going to be electrostatic analyzer, EESA, and also ELP, floating potential probe. Okay, slightly sticking up there, but not really that super big. It's basically like just around the area where of the left side where the electrostatic analyzer stands. Okay, solar panel, RCS reaction control system, the RCS propellant tank, and also the engine nozzle, aka the thruster itself, where it's located. Okay, and it's not really that big. It's around, at max, let's just say, for the sake of brevity, it's not even reaching 2 meters of overall sizes there. It's more like 1.2 meters by 1.65 meters by 1.09 meters. Okay, and yeah, when it deploys, it will be deploys pretty big there, around 4.88 meters by 1.65 meters by 1.09 meters. So basically, when it unfurls, it will just go from 1.2 meters to 4.88 meters. Okay, and mass itself, the dry mass when there's no propellant loading there, it will be 209 kilograms, but fill-in will be 555 kilograms. And yeah, the propulsion itself, I mean, some of you might know actually this name, so I'm going to please. It's going to be obviously a hypergolic propellant. It's not particularly the most green propellant there, pretty nasty can be, but if not really that much, technically can be okay-ish. It has a little bit like mixed oxides of nitrogen, MON, and also the monomethyl hydrazine, MNH here. While the reaction control system, the RCS thrusters, it's going to be using cold gas nitrogen thrusters. Basically, it can be capable to do rotation and also translation. I mean, if some of you learn a little bit of mathematics, you know what is this, okay? And yeah, I'm not going to bore you a little bit too much specification. And yeah, the power nominal for the science mode power draw usually about 128 watts. I mean, not bad. Usually when it uses for the science mode power draw, it's mostly plus minus, like if you're trying to use your power brick around at home, And also power generation at Earth, it will be at 800 watts, but power generation at Mars, aphelion, I believe this is the highest point of the altitude of the Mars, will be 288 watts. I mean, like, not bad. It's like your desktop's slash a little bit of gaming laptop power generation specs there. Not bad. And yeah, and energy storage, it has like 57S5P battery assembly, so that's that. And yeah, it does have 2 star strikers and also 4 fine sound sensors there. And actuators, it says here, for reaction wheels, reaction control thrusters, and yeah, I'm not going to bore you. Yes. So for the communications, usually they plan to downlink around 45 gigabits, and yes, it does have the X band radius here. Okay, uplink and downlink will be X band. Yeah, so I was mostly right there, except the fact that I did mention about the car and also S band. So most of this mission would be the X band, around how many gigahertz if I remember correctly. That's practically a little bit comparable, to what even some of the satellites actually be used. I think some of the geostationary of orbit satellites use also does have X band. Yeah, but mostly for the military side. But yeah, because you want to send that data, obviously you have to use that radio band, and I believe they might already got this permission from that side. Okay. All right. Looks like we are almost ready. Oh, this is good. T-minus 5 minutes. Yeah. Okay. So this is the by the way, just to speed up a little bit, this is the launch mission itself. Okay, the liftoff, and after that it will be ascent, which will initiate the gravity turn, and then it will have stage separation, and then attempt to reorient the maneuver. Okay, let me see. Yes. Okay, reorient maneuver, where the first stage actually starts, and then booster landing burn, and then booster landing at the Jacqueline drone ship there. And then after that will be frame separation, escapade separation, and CSP payload turns on. Okay, and this is why I said I'm not going to say too much. The inclination will be around 29.5 degrees. Okay, the argument of perigee would be negative 179.7 degrees, and obviously the launch site is LC-36. This is where Atlas rocket launches used to be up until around, if I remember, the 2AS if I remember. Yeah, and then not being used for 20 years before finally, yeah, almost 20 years before finally Blue Origin finally launched it for the first time. But LC-39A and B basically being already merged together. The B side already demolished, the A considered as the new upgrade. So basically that's that. And this is the mission timeline. I'm not going to bore you too much. Around T-minus, and then we are going to talk a little bit. Terminal counts has already begins, and right now we're getting ready at T-minus 2 minutes and 30 seconds. The tank pressurization will begins, and T-minus 1 minute and 30 seconds vehicle on internal power, and then later at T-minus 30 seconds simultaneously the water deluge slash the sound suppression water garden systems will turn on, and also autopilot enabled. And then T-minus 5.6 seconds of the 7 BE4 rocket engine will ignite, and then T-minus 0 seconds will lift off, and then around T+1 minutes and 35 seconds will be max Q, maximum aerodynamic pressure, fully exerted on the launch vehicle, according to the velocity of the launch vehicle. When it goes up, and it will reach the max point of the atmospheric pressure and whatnot, and then T plus 35 and then T plus 3 minutes and 5 seconds, MECO, main engine cutoff, and then later T plus 3 minutes and 9 seconds, stage separation, and then later on would be T plus 3 minutes and 17 seconds, stage 2 engine ignition, the SECO, and then after that T plus 3 minutes and 50 seconds, frame jettisons, and then the rest. I'm not going to bore you. Okay, and then at some point around T plus 33 minutes and 80 seconds, the ESCAPADE Blue will separate, and then followed by 30 seconds later, T plus 33 minutes and 48 seconds will be the ESCAPADE Gold spacecraft, and then later on 5 minutes later at T plus 38 minutes and 48 seconds will be the viasat in range tech demonstration will turns on, and then it will test for the new space communication there. Okay, so let's go there. All right. All right. So let's go. Okay. Flight level. Let's go. Oh. Oh no. Hold. A little bit hold. Oh. T minus 20 seconds. What happened? Hopefully we are still going in. Oh no.
Alright, as we've seen here, our team has decided to go into a hold at T minus 20 seconds.
Oh. Still. Oh, really? Oh no.
Let's wait to learn just a little bit more here.
Alright. I think... Alright.
Auto-saving complete.
Okay, auto-saving complete, and probably we are getting ready for the launch itself. So let's go. And yeah, we are holding at T minus 20 minutes, 20 seconds, sorry.
We are awaiting here
So yeah.
NG-2, the second mission of New Glenn. We are at T minus 20 seconds. Our team has decided to enter a hold here.
Okay, hold a little bit.
On other webcasts before. We spend years designing this rocket, months building it, months designing the missions. If we need a couple of minutes to make sure that the rocket is ready, that our team is ready, that everything on the range is ready,
that's right,
then we will take that time.
At this moment in time,
by the way, if you by the way, if you hear a little bit of the notification there,
right now you've got
I'll say thank you for
the
actually
twin satellites,
thank you actually for
They're
reposting
ready for
my post there on the Mastodon. If I remember the PK1 power from space like that. Yeah, thank you so much. Oh, no, or PK's power from space one. So thank you so much for actually repost my stuff from Mastodon here for today's launch, especially because I already notified from the post. Thank you so much. I appreciate it. Yeah. I mean, interesting. Even yesterday, I didn't have the opportunity to go stream yesterday. Even then, there still repost it. And also, yeah, I need to tell you something. I'm a little bit shocked, not like shocked, it's like I'm a little bit surprised that actually people do care about this topic. Actually, that's why it's pretty interesting. So thank you so much. I really like it. I really like it. You like it. Everyone's wins. And you can see this is the background view. They are still waiting around T minus 20 seconds, and yes, I think in the meantime, why not? We change a little bit, right?
If you're just joining us, this is NG-2. We are at T minus 20 seconds. We are currently
nice.
We had a terminal count aboard.
This is the view.
Like I said, is currently investigating. So while everything is getting sorted out, we're going to toss it back over to NG-2 on the pad and give you more information as it becomes available to us.
That's a little bit slow. Okay, and this is the website itself by the UC Berkeley themselves. Okay, you can see. Yeah, low-cost planetary exploration for NASA here. Yeah, and you can see. Oh, so especially the ESCAPADE, it's basically a twin spacecraft class D missions there, okay? And it says here the measurements they want to know about the plasma. About the plasma measurements at Mars. It says that why do we actually care here? They say. So let's try. Look at this. We click on the about. Okay, and this is the website in case you want to go. You can visit escapade.ssl.berkeley.edu. Okay, just try go to this website. Maybe I'll give you the link later on for you to actually read here and there if you want. Okay, so yeah, they are basically also, it says here specifically it says that they are dedicated to studying the transfer of for this mission, dedicated to studying the transfer of solar wind energy and momentum to Mars, unique hybrid magnetosphere, and basically how it drives ion and sputtering escape. Okay, so here you go. And also they're going to characterizing both space weather and ionospheric variability, which basically it says obviously which disrupts communication and navigation systems at signals at Mars. So basically that's why you know why the ESCAPADE didn't launch yesterday, because of that concern. Okay. Oh, so basically it says here that this mission does breaks the paradigm of multi-hundred. Okay, you can see the Jacqueline ground ship there, live view. Okay, ESCAPADE, it says here that it breaks the paradigm of multi-hundred million and billion-dollar planetary mission, and it says that it builds on the Maven Mars orbiter's legacy, basically for the fraction of the cost, less than 80 million US dollars. So that's that. And yes, it does led by the UC Berkeley Space Sciences Laboratory. So basically that's why it's called as SSL here. Basically they are responsible for the mission management, system engineering, science leadership, navigation, operations, the electron and ion electrostatic analyzers, and science data processing and archiving for future revisitation at some point. And you can see the live here. This one is the view. Okay, really good. Is this 60 frames? I need to check, because it appears like this. Oh wow, this is 60 frames. Okay. Okay, hello. If only my laptop ain't that potato, I would actually space. Okay, but trust me, this is actually 60 frames. Oh, what happens? Usually, if they remove that T minus whatever, usually it could means scrap. Ah, no, please, please, no. Not another scrap there. Oh no. But I guess better scrap than RUD, I guess. And yes, RUD that I mentioned, RUD, actually stands for how do I say, rapid unscheduled disassembly, or just another word for rockets goes kaboom and goes wrong. That's basically what RUD actually means. Okay, and yes, the key partners obviously it's going to be Rocket Labs, USA, the spacecraft manufacturer itself, and NASA Goddard Space Flight Center, the magnetometer part, the Embry-Riddle Aeronautical University, the Langmuir props, and also and Advanced Science, Advanced Space LLC, the mission design, and also the Blue Origin, this stream you can see yourself for the launch itself. Okay, and let's visit for the science itself. from the website. While we are still waiting, yeah, you can see why. This is basically the same science goals and objectives, basically to study the transfer of solar wind energy and also the momentum through Mars's unique hybrid magnetosphere, and also how it drives ion and sputtering escape. And it's actually built at, on the Maven's legacy for the fraction of the cost, around 78.5 million US dollars. So you can see here you can see how they are going to do a little bit of study here. Okay, you can see why. That's why they want to study this. All right, you can see the shape there. Okay, so apparently this mission also actually were inspired by the Cluster 2 mission. Yeah, and if I and also I want to tell you something, that originally the original Cluster mission also functionally identical to the Cluster 2, but as you know from the history, the Ariane 5 first launch is basically ended in disaster. Okay, and the reason is pretty much very simple, because the rocket itself accelerated too much, and they didn't test the software side, that they forgot that those 32-bit to 16-bit conversion actually is not really that correct. Okay, because remember back when Ariane Space actually built Ariane 5, especially the design, they actually inherit some of that legacy from the Ariane 4. Okay, so they forgot to change that software conversion to the point that where the 32-bit floating point to the 16-bit integer conversion happens while it's accelerating, the rocket on board itself, both of the main and backup, cannot actually cannot translate what it says, and basically goes panic and says, "Go turn hard left now," and then it launches, and then it basically destroys the rocket and also the payload and also payload frame itself. So clusters end up in mission, especially the original clusters and also the Ariane 5 first launch, ended up failure in June 1996. So after that, they basically came back around 97, if I remember correctly, for the Ariane 5. So yeah, but again, this mission is pretty good. Okay.
The escape and plasma acceleration.
Oh yeah, you can see it actually have like how many? Four, if I remember, 4 spacecraft actually for the cluster, for both the original cluster and later the successful cluster 2 missions there. Okay, by the ESAs, and also the Themis mission, Van Allen probes, and also the magnetospheric multi-scale, the MMS mission. Okay, pretty interesting. Yeah, I think I'll just keep it there. You can say pretty interesting. I mean, actually, I like this spacecraft design most of the time here. I mean, it's pretty cool, right? It's like a small cylinder block with Langmuir, with the magnetospheric, and also presumably some of the Langmuir prop there. I mean, it's pretty interesting. I like the design. So yeah, so basically, originally this is designed for the research on Earth, but they will apply this to the Mars, of course. And here, science objective. I believe it will go to the same, almost similar page there.
ESCAPADE will also help us.
Oh, okay. So this is more detailed one here.
ESCAPADE will give scientists more details about Mars's
atmosphere, and
that future astronauts will use to send
so
radio and navigation signals around the planet. ESCAPADE's work could also help keep future Mars explorers safe.
The atmosphere can provide a shield that protects humans and
so that's why. And the mission itself actually has 3 goals that actually leads to 7 objectives. From this website, it says the goal A here is to understand the processes controlling the structure of Mars' hybrid magnetosphere and how it guides the ion flows. As you can see, this is the mission A here. The two objectives here would be basically to study the magnetic tail, and also A2 is to, and also A2 to actually study the escape plume itself. You can see on the first goal A here. And after that, the goal B, the second goal will be for them to test, to understand how energy and momentum is transported from the solar wind to Mars magnetosphere. So that's basically why. And they are going to study at least around four objectives here. Okay, the B1 they are going to study about. Oh, here you see on the payload itself, the ESCAPADE Blue and Gold here there. Okay, but we are back again. The B1 they will study about the bow shock flow, and B2 they are going to study about the magnetic shift and pile up boundary. And the B3 they are going to study the terminated flow, and also B4 the tail sheaf flow. Okay, so that's it. I don't want to try to unintentionally mispronounce it incorrectly, so that's why. And the
That's right, Ariane. So if
okay, and also the goal C, the third goal finally would be for them to understand the processes controlling the flow of energy and also matter into and out of the collisional atmosphere. So that's why. Oh. Okay, it's resetted back to T minus 32 minutes and 50 seconds. Okay, so I'm almost finished with this mission briefing for us to learn about this mission here. Okay. Okay, so here on the goal C, they are going to study two missions there, or basically what two objectives there. They are going to study both the outflowing ions and also precipitating ions, so they are going to study that too. I mean, that's why I really recommend this website. It's very detailed what you're going to study. Okay, so for this ESCAPADE mission, according to this page here, there is like the plasma measurements at Mars. Okay, wait, where is it? I think here is probably complete. Okay, so why do we have to care about the plasma measurements at Mars? It says there's basically like two reasons why. The first is actually to understand the structure, composition, variability, and also the dynamics of Mars' unique hybrid magnetosphere. Okay, and also second is to study the atmospheric escape processes around the Mars, and also applicable to us here in space. I mean in Earth. It's actually to study the ion escape and sputtering escape that might help drive the climate evolution of terrestrial planets, especially us here in Earth. So that's why you can see interplanetary magnetic fields, and then solar wind photons, penetrating photons, and you can see cluster magnetic fields, for shock waves. So they are going to study like this: deflected solar winds, magnetic shift, and precipitating energetic heavy ions, which leads to sputtering escapes, tail instabilities, backflowing heavy ions, magnetic reconnection. I think there is actually one definition. I think if I remember, one of the things that I actually heard is about the Kevin Holtz instability, something like that. So that's also something I learned, but that's not a bit precise than that I told you. So we're going to see that. And then magnetic tail, low energy escaping ions, ionosphere, tail is instabilities again, and then magnetic pile-up boundary, magnetic shift again, and then plume of energetic escaping heavy ions. So and bow shocks. So basically that's that. Okay, and back when Maven actually still operational, it paints the average picture of a dynamic magnetosphere. So it studies the ion escape plume, and then global current system, and then later on injection and drift of electrons trapped in mini magnetosphere, electron acceleration which leads to aurora. Okay, especially some reconnection stuff there if I remember. I mean, then magnetotail twisted by cluster fields, and also plasma clouds escaping via snowplow effect. So that's that. Okay, but it says here these processes and more are dynamic in space and time, and back then Maven actually cannot distinguish between these two things: the spatial and temporal variability, and also cause and effect. And it says here the solar wind disturbances propagate through system in 1 to 2 minutes, and Maven it has time lag of about 1 hour, more than 1 hour. So that's why they want to study this much more quicker. Maybe they try to make time lag as little as possible, maybe 30 seconds or whatnot. So we'll see. And yes, it says here that a single measurement platform really leaves major questions unanswered. Basically, spatial and temporal variations in escape fluxes cannot be distinguished, it says here, and also responses of escape fluxes and other dynamics to changing solar wind conditions around 1 to 2 minutes can only be measured with a time lag of an hour or much more, which the same problem literally faced terrestrial space plasma physics in the 1980s and also early 1990s. And yeah, single spacecraft alone will not be enough to characterize plasma boundary dynamics. And it says here the multiple spacecraft will allow the 3D time resolved measurements to create a dynamic picture of the magnetosphere and how solar wind conditions affect it. So that's why they are launching a twin spacecraft there to the Mars. Okay.
NGS-2, and that is
okay, the mission design, if we can try see.
To catch up with Dr. Joe Westlake to talk about solar weather effects and how that can affect satellites and what we can expect
next
from the deployment
space flight
of ESCAPADE.
here. Let's try look at here.
Dr. Joe Westlake, heliophysicist at NASA. We are so honored to have you here with us in the studio. First off,
okay, so now
heliophysics.
Yeah, so really excited to be here. Really excited to see.
4:45 a.m. Here local time, my place of course.
Is an interesting word.
But wow, we are slightly a little bit late.
It doesn't exist in the dictionary yet,
But
which is really an
hopefully
interesting thing. We hit our slang era in heliophysics.
Okay, and the mission design here, you can see.
Heliophysics is like
what's the mission in the nutshell here?
ESCAPADE, folks would say, well, like, what does heliophysicists have to
Okay,
do with
we'll launch
Mars
blah
mission?
blah.
What do we care about
We'll
what
launch
the sun
we'll
does
go for
to
1
Mars?
year.
Well,
Kidney bean
ESCAPADE
shape
is a space weather
approximity
mission. We're going
space
out to
built for
ensure and
returning to a
protect
low
the space
altitude
weather,
perigee for returns to Mars.
effects on Mars,
Injection
on our
TMI,
astronauts, on our
engine burn,
spacecraft that
and then
are
will
on
take
Mars.
place
And as we saw
a year later in
space weather's kind of a
2026,
big
November
deal.
It certainly
2026.
is. Can you kind of talk
And yes,
about how
basically
space
we'll
weather
take advantage of
affected
the
our launch?
Yeah, so
orbital
heliophysics over the last couple of days
low
got to see some
mechanic
really
effect
pretty,
there,
light,
which will send blue and gold
as they call it.
on the way to
You know, we
Mars
saw
itself.
across the US,
Okay, so you
even
can
down
see
here at,
this is how it looks like.
the Florida at the
View
Space
from
Coast,
the above
right?
here.
We saw red
The
aurora
to Sun,
over top
Moon's
of our
orbit.
rocket.
Okay,
And that's
and
really
you can
cool.
see
Like, that's a pretty
it will
light
be
show,
placed
but what
around
that
the
really
Lagrange
means is that the
point there,
magnetosphere is kind of angry,
in
right?
between
It's got
point
a
of
lot
the
of
Sun and
energetic particles
Earth
that have
itself.
come in
Okay,
from the sun, right? A coronal
okay,
mass
and
ejection
apparently this is
came in,
also going to be the
multiple
first
coronal mass
mission ever
ejections came in
to harness
from
a
the sun, and they
Sun
pushed
Earth
into our magnetosphere,
Lagrange
creating,
point
space
2
radiation
orbit en route to Mars. So basically, this is the actual mission. And yes, as far as I know, this is will be the first time ever such mission will actually uses the auto Lagrange point there to go to the Mars. So that's pretty interesting. I think it's not bothered much by the space and times. I mean, it's still some, but not as strict as before. So that's why.
You know, when we go out to Mars, right, we're looking at how space weather, how the solar wind,
Yeah,
how
so
coronal mass ejections
what
and
they're
flares
talking about,
impact the Martian
and they said here that they will execute a typical ballistic Hoffman Type 2 interplanetary trajectory with several trajectory correction maneuvers (TCM), and will arrive at Mars in September 2027. So yeah,
and the water and the ocean.
interesting. You
You
can see
so different, right?
Mars injection 2 times, and then TCM1, TCM2, 3, 4, 5, 6, 7, 8, and then after that Mars orbit injection for both of these spacecraft. Okay, mostly at the same time. The goal, yeah, apparently, gold, from what I can read, this is basically will be 2 days apart. Gold will arrive first on 7 September 2027, and then later on blue 2 days later on 9 September 2027. So, yeah. Okay, for the Earth departure, blue will depart first on 7 November 2026, followed by 2 days later, which will be gold on 9 November 2026. So yeah.
2 years a window opens up where you can make the most efficient trip to Mars. And all that
And
means
it says here that the Mars orbit insertion will put blue and gold into a large capture orbit. So that's why.
How many Mars missions can we get
For
off
the
the ground
both of the
in
capture orbit for the
that little window,
blue
yeah.
and also the
One of
gold
great
itself,
things,
you
one of
can
the
see.
innovations that we're doing here with
And Mars
SIMPLEx
orbit
is
insertion
we're
burn
gonna
apparently will last
We're gonna send
for
it outside
11
of that
minutes
window
after
because
that.
we can put it
From
into
cruising,
a
this
very
one is
benign,
viewed by
safe
Earth.
working orbit,
Here
and let
how
sort
it
of hang
actually
out,
goes.
loiter, hang out
Yeah.
near us here at Earth.
So pretty
we can make
interesting.
some measurements about the space weather here around Earth, and we can prep
Yeah,
for those
and if I
spacecraft
remember
to land
correctly,
with
the
their own propulsion,
blue
get
orbit
themselves
will
out
be
to
around
Mars when that window
10,000
opens.
kilometers
We always talk about how,
highest point of the
spacecraft are frankly
altitude from the
safest
Mars,
out in space,
while the
right?
gold
There
will
aren't
be 7,000
hurricanes
kilometers
or other things
highest
to worry about
altitude
when they're out in space.
from
And
Mars.
plus, we always
But
love to have
the
amazing data that
lowest
comes
point
from
of the
spacecraft,
altitude will be the
almost no
same.
matter where they are.
Certainly.
Will be
And
the
what's
same from
interesting is we're
Mars,
sitting here in
which will be
2025, but this
180
mission is really
kilometers
going to take
of
it's
altitude.
5 years when you also count all the way to when we're going to get the data
Yeah.
that starts
Oh,
to come
okay.
back, right? So
And then after that, they
2025,
said
around
that they will
2027 is when
they will
ESCAPADE
try to
will
spend
actually
it
be at Mars,
for
and
the
then
next few
that's
months
kind of
around late
being
2027 and
reoriented.
also
Is that my
early
understanding?
2028
We have a couple of
to
different orbit
reduce and
scenarios
also
with
synchronize the
ESCAPADE, 'cause
orbits of
we have different
blue
questions,
and
right? So one of
gold.
the questions is,
So
I
here
wanna be
is
able
the
to
radius
follow,
of
have a leading
of
following
upper
orientation of the two
apsis,
spacecraft, and I want to see
highest
how
point,
those
and
are
also
behaving in time
periapsis,
by doing
lowest
that.
point.
But
Oh,
then we're
so
also
they
gonna
use that.
spread them out
But
in
there's also another
longitude,
word
so
for that.
like east-west. And we're gonna
If I
fly
remember
them
up
somewhat side by side. And then we're
ARE,
gonna
if
ask
I remember
questions that are like,
ARE,
okay,
it's
what's
basically
inside the
referring to
Martian
the Mars.
atmosphere
So
versus the
you can
outside?
actually insert
There's a
like
lot
this:
of dynamics and other
upper
things that we
aris,
can do with these, you know, really
upper
two very capable
perigee,
spacecraft
and
that we're sending
also
out to Mars.
And another
perigee.
cool thing about your mission is
So
you get to work
that's also
with
another
Dr. Nikki Fox.
way
I was
to
able to grab
say
her
it.
into our
Okay.
webcast the other day,
Yes.
but today's a special day.
Okay, and then after
Yeah,
that
it's a
it
really
will
special day.
synchronize.
So, you know, when we think about, we talk about having
And also
lights
the
and
ESCAPADE
lighting
science
candles and other things. You know,
drives
this is her
mission
birthday, so
design
we get to
here.
light a candle today. I think it's going to be really amazing
Okay.
to be able to,
Quite the
you know,
birthday candle.
And
obviously
we can study a little bit mission orbit mission here, especially because it has two science campaign, or technically would be three.
Go NG-2.
So yeah.
Excellent. Go New Glenn, go ESCAPADE, and we're just so jazzed to be here.
And we're so grateful to have you as
Yeah.
a customer. Thank you so much.
Thank you so much.
So technically it will be like this. The science campaign A will actually last from
not in the dictionary, and he gave us so much good information, of course, on
it will
what we're
last
affected
from
by, essentially that solar
January
weather. So right now,
2028
you are
until
looking at New Glenn on the
15
pad
December
as we await
2028,
the launch
which will
of
last around
NG-2,
6
L
months.
minus about
And
20 minutes.
perhaps
But let's
altitude
take it
will
back
be
over to our very own
lowest
Eddie
point of
Sanford,
the
who is
altitude will
with
be
the
around
employees right here at
160
Rocket Park at
kilometers.
the
Yeah,
best
my
spot
mistake.
to
It should be
watch
160, not
New
180.
Glenn take
But
to the skies.
whatever.
Eddie, how are things over there?
I think not really that far.
Hey Tabitha, hey
Oh,
Ariane.
whatever.
We are on top of the
Okay.
world. That's certainly
And
what
then
it feels like
and
on
after
this
that, the
momentous
upper
occasion.
apps
And
altitude,
I changed
the
up the view a little
highest
bit.
point of
Behind
the
me, you see
Mars
Lunar Plant 1. That's
from
our
the Mars
newest
would be
building at Rocket
8,400
Park. Now
kilometers,
Rocket Park
and the
sits
inclination
on
will be around
250 acres
65
of what used to be
degrees,
an orange grove. That was
and the
pre-2016.
orbit
Since
periods will be
2016, we've added 2.5 million square feet of
5.66
production
hours
space at
here.
our newest building. It's
And
building
it
the
says
lunar
here that
landers
this
that are going to
string
help
of pearls, it will
NASA and help
optimize
Origin
for
return
studies
to the
and
moon this time
of
this year.
short timescale variability, and also
And I think we talked about this a
the
little bit
campaign
on our
A
last
to campaign
webcast.
B
That
transition
building
will
behind
occur
you is
around
massive. It's hard to tell because you're
December
elevated
2028,
yourself.
which
But
blue,
maybe you can
it
talk a
will
little bit to
lower
the
its
scale of that building,
highest point of the
as well as
altitude,
its
you can see here,
location
to
relative
7,000
to
kilometers,
other facilities here at
while the
Rocket Park.
gold will actually raise
That's
its
right, Ariane. If you're
highest
ever
point of the
driving that Space
altitude
Commerce Way, you'll see it. You'll
from
see
the
just
Mars
how
by
massive it is.
10,000
Right? If I'm
to
standing on top of the
10,000
world and that building's
kilometers
even
of
taller,
altitude.
it's tall
Okay,
enough
and after that,
to house
then
the
that's where the
16-meter tall
science
lunar
campaign B
lander,
will
which is
begin
twice
on
as big as the
from
Mark
16
1
November,
101
no,
Pathfinder
from
that we're going to
16
launch to
December
the moon later this
2028
year.
until
When that lunar
15
lander lands on the moon,
May
it will be the
2029, yeah, until
largest
15 May
lunar lander
2029,
to have
which
ever landed,
will
and we're
last
just going to get bigger from there.
almost,
So we're very excited about Mark 1
yeah,
later
which
this
will
year
last
or early next year, and then Mark 2
6 months
to
or around
return
6
humans to
months
the moon
like
this time
that.
to stay. And you mentioned the
It says here
co-location.
that the
So the
preview
fact
apps
that
altitude,
we
the
can be
lowest point of,
co-located with New
from the
Glenn
Mars
means that we can
altitude will be
encapsulate that very
160
large
kilometers,
lander
the same,
in the very
while the
large New Glenn ferry
upper apps
here on site,
altitudes,
and
the
then we can
highest point
drive
of
it out
the
to our integration
altitudes
facility
for the
to
blue will be
essentially place
7,000
it
kilometers,
on
while
top
the
of the New Glenn
gold
vehicle,
would be
much like we
10,000
have Escapade
kilometers.
today.
And the inclination both still same,
Eddie,
65
thank you
degrees,
so much.
but the
Always so great to talk
orbital
to Eddie because
periods
he
will
can talk at
be a
hours
little
and
bit
at
different
length
there.
about anything to do with
The
engines, with lunar, and of
the
course these
periods,
are hyping out there with
the
everyone
orbital periods
here at Rocket Park.
for
Thank you again.
the
If you didn't notice
blue
on
will
his
be
shirt actually are
4.9
little
hours,
lunar
almost
labels
5 hours,
as well.
while
But right now we're going to toss it
the gold
over to New
itself,
Glenn
the
on the
orbit
pad as we
periods will
await the
be
launch of
6.6
NG-2.
hours,
In
almost
about
6,
30 seconds here, we're
around
going to
a
hear
bit of
another
6,
gold pulse. So let's go ahead
6
and
plus,
listen in.
6.5 plus hours of orbit periods there. Yeah, so you can hear what it says there. And it says here that the orbit planes actually precess differentially. It says that this one is to optimize for studies of correlations between more distant regions, example the solar wind and ion loss in the magnetic tail. So that's why. Okay. And then the ESCAPADE spacecraft, I don't think I should. Yeah, this one, the schematics we actually already read from the rocket lab, so I don't think we should cover too much, but we can go a little bit there. Okay, the solar arrays, of course, is going to be fixed, and it will be 2 meters boom that's sticking right through it of the EMAC and also MNLP. Okay, and it will be a 60 centimeter fixed antenna. I mean, if I remember correctly, even in my course, actually, even in my computer science course, actually we study a little bit about how the antenna size calculation actually were done. Okay, and from what I know, it's basically like this. The bigger, how do I say, the bigger the hertz and the frequency of the bigger the frequency and also the hertz of the frequency band of the of the signal, actually the smaller you can actually make the antenna itself. Okay, but that's basically how it actually goes by with the mathematical calculation and whatnot. For example, if I remember the 5G antenna, if I remember, there's actually something like two types of the calculation in small stuff. Okay, apparently we have hold at t minus 17 minutes and 4 seconds. Looks like it. Another hold. Okay, if I remember, there's some calculation. There's two types. If you want to make a much more portable antenna, you can actually use the calculation lambda divided by 2. No, lambda divided by 4. That one is actually the smaller size. That one is basically the quarter antenna size. While if you want to build pretty much a standard antenna size, you can use the lambda divided by 2. So yeah, we actually learn this stuff actually. So that's why I actually can understand why the antenna size for the spacecraft missions it's like that. Okay, because that's why there's some calculation there. You want to use some types of frequency band there. If I remember, let's try search for the X band. X band. Okay. Yeah, so you can see it's actually from 8. Yeah, it's actually, yeah, if I remember, let's see. Yeah, so basically the frequency range is basically around 8 to 12 gigahertz. So even if I calculate, I can actually understand why it's actually going to be 60 centimeter of fixed antenna size there, you know. So I understand behind the physics, not really 100% physics, but behind the calculation of math calculation of this one. So I understood why. Okay, and then it says here, obviously it's going to be continuous in situ data collection. In situ actually stands for the on the site calculation, so that's why. Okay, and it says here that the cadence, instrument modes, data products, and orientation will be optimized for collection above and below 1000 kilometers of altitude, so that's why. So here you can see the animation. Okay, I'll try to show a bit here. Here it's basically created by the Rocket Lab USA Incorporated. So this is how the missions look like. Okay, so don't mind with a little bit of slower stuff video here.
Welcome back, everyone. You are currently watching NG-2. Now we are waiting to go full for terminal count. Right now we're in a hold and we're getting more information. Do stay with us. Keep your eyes on that screen because
okay, and also the animation of ESCAPADE Blue Gold here.
Fantastic.
It says here the green cone is the field of view of the ESA electrostatic analyzer instrument, basically to measure ions and electrons. You can see here. This one is the 100 times view of this, the 100 times fast motion here, just for you to watch. I think I'll try. Okay, so this is how it looks like here. Yeah, so okay, I believe this is a translation one. Yeah, you can see. Pretty interesting. Oh, so the thruster will heading mostly towards the sun, while the velocity will go in front, and also the mass. Yeah, it's just follow what is it, right? Yeah, pretty interesting. Interesting view there. Interesting. Okay. So let's try go with the instruments. Oh yeah, and for the science operations there, maybe I'll try to cover once more, but mostly on the time scale there. And yeah, ESCAPADE instruments inside there will be the magnetosphere provided by the NASA Goddard Space Flight Center, and the electrostatic analyzer will be contributed by the university themselves, the University of California, Berkeley, you see Berkeley and ESCAPADE Langmuir prop suit provided by the okay, ERAU, yeah, and also the VIS and IR infrared camera will be contributed by now and AU. I mean, too much to say here. I mean, you can see there's a little bit of stuff here, but the magnetosphere, it will, of course, it's going to be to have EMAC. It will inside there will be the DC magnetic fields instrumentation there. Okay, and mass, the MEV itself will be the 450 grams. Okay, looks like it's already still holding. Okay, holding at T-minus 19 minutes and 45 seconds. Okay, and this is the launch pad view from the top. Okay, looks like T-minus 19 minutes and 13 seconds. Looks like the launch still continues, and the weather looks pretty good. The weather range is also pretty good too, and hopefully it's not going to cancel anymore, because yeah, if they cancel this too much, it's not going to be able to launch properly. Okay, it says here hold, but mostly no. Yeah, if I remember, this should be the
on New Glenn. This is NG-2. We're at L-minus 18
yeah.
minutes and about 40 seconds. Now, coming up at the 17-minute mark, we will have that poll for terminal count. But Arya, right now, I want to talk about how incredible
the mass, the MEV itself is 450 grams on the magnetosphere, and the power usage in the CBE itself will be 1.3 watts, and then the data rate will be data requires will be around 21.5 baud per second, if I remember correctly. What actually it stands for, BPS, it actually stands for baud per second, if I remember. Pretty small data usage. Wow, that's pretty good. And for the electrostatic analyzer, there's actually two of it. The one version is the -I version, the suprathermal ions, and the -E would be the suprathermal electrons there. Okay, and the mass itself, the MEV will be 5.34 kilograms, while the power itself will be the 6.1 watts of power usage, and the and both of the data usage will be the would be 183 plus 67 baud per second here. BAUD, of course. Let's try calculate here.
It's a beautiful rocket. I cannot see it do its thing this first time in just a couple minutes here.
So let's try calculate here. 183 plus 67. It will be total usage of 250 bauds per second. I mean, it's pretty good. Surprisingly good. Not using it that much. And let's hear for the terminal count first. Go and no go. Okay, so where's the sound? Maybe not yet. Oops, sorry. Let's listening first before I decided to just pause it. Okay, so apparently they also have individual pages. Okay, maybe we'll go and still talk a little bit. Okay, and you can see there's a little bit of methane burning there, because of course it's actually venting right now, but it keeps replenished by the propellant line itself. So yeah, you can see on the background there here. And let's see also the ESCAPADE Langmuir prop suit here. This one, there's actually three sub instruments here.
We have New Glenn on the pad, and the reason I have my computer
the first one is the MNLP, the thermal electron density measurement, and also the planar ion props, the FIPS, will be the thermal ion density, and also the floating
Never
And
tell
also the
what the
floating
odds are
potential
and a
probe
great day to
FPP
fly.
will be the
Beautiful day to
relative
fly. Looks a lot better than it did on Sunday.
SC.
We were
What is it?
just constantly fighting the Florida weather down here. It would be sunny,
Oh,
and then it would be rainstorm, lightning, and then it would be
I don't have a
sunny
little bit idea
again.
what they
It
talk
was
about
just,
the
it was a
SC here.
lot
Maybe
going on.
I'll check later.
But today
Relative
is a
SC
beautiful,
potential
beautiful
here,
day to
and
fly.
also
So, as you mentioned, right now,
for
L-minus
the
15
overall
minutes to go from New
mass, it
Glen's
will be
second launch. And Tabitha, you
538
recently
grams,
had the chance to
including
chat with our
sensor plus
CEO,
the
Dave
port
Limp,
mass
about
itself.
NG-2, today's mission.
And also the power usage will be
For
0.95
and for our company.
watts,
Yeah, you can
around
see Kent right there
915
on your
milliwatts.
screen. Hey guys, giving you lots of love
And
right here
the
from the desk. Also thinking about our guys
data,
in Huntsville,
apparently
Alabama,
it's called as
Van
data
Horn,
square.
Texas, and
Okay,
of course,
and
right
also
here at
data
Rocket
square,
Park. Now,
the
when
same
I
with
got to
the
talk to Dave,
electrostatic
not only did he share his
analyzer,
message to the
but
more than
here the
10,000
data
employees
square
of Blue Origin, some of which you see on your
for this
screen, but also how important
lung
NG2
mirror
is
prop
to
suit
focus on
will
for our
be
customers.
10.8 watts per
This
second,
is a really big
BAUD
moment for Blue
per
Origin.
second.
Can you tell me
Wow,
how
that's actually
NG2 compares to
pretty good.
NG1?
Yeah, I think NG1 was obviously
Okay,
our first mission.
and
There was
also
lots to learn, and we did
here
learn
you
a
can
lot,
also
and
see the
unbelievably
bridges,
successful in that we made our
and
goal to
IR
get to
infrared
orbit.
camera.
This time we're
The
going to be
grid
a little bit
itself,
more
the RGB
ambitious.
sensor,
We want to not only
it's
get to
39
orbit, but we have our
degrees by
first
33
paying
degrees
customer this time
with
with
45
ESCAPADE
meters per
and get them off
pixel
to Mars.
at
That's the first part of our
periapsis,
goal,
and
the second
also
part of the goal is to land the
3.2
booster out
kilometers
on
per
Jacqueline. And,
pixel at
if we don't, we have more over
apoapsis.
here in the factory that we're
And
building,
while for the
but we're going to give it
that
our
one
best
is
shot.
actually for the
Never
breeze,
tell me the odds.
while
It's
for the
pretty fitting for this booster. You know,
well,
we're
for
having our
the
second
infrared
attempt
camera, it
landing
will
it for the
be
first time.
8
How are
to
you going to feel if we
14
land?
micrometers there,
Well,
around
I certainly
45
will not
degrees
channel
by
my inner
37 degrees.
C-3PO. I will be very
And
ecstatic.
for the
I'll be able to put some
periapsis,
needles
it
up
will
to
be
that point, but it
460
would be
meters
a
per
huge
pixel,
achievement
while the
for the team and for
apoapsis, it
Blue.
will be 34
I think that we
kilometers
have a
per
good chance, but
pixel.
if we don't, like I said,
So
we
that's
can
the spec. It's
build more,
interesting, and
but
the mass
I'll be
itself,
open if it
the
happens.
mass will be
Now, New Glenn is obviously
603
just one of the many
grams.
systems
Oh,
we
yeah,
have here,
pretty
right? We have New
interesting.
Shepard, we have Lunar, we have in-space systems. How are all of those organizations really
Okay,
working together to further our ultimate goals?
Yeah,
let's go
each
on the
component
individual
of what we
pages
do
because
has a piece
something
of
else
our
we can
engine.
actually
It's
cover
people
here
that work and live
and
in
there.
space, and they all have their
Okay,
thing
T
to
minus
do, but
12
as it
minutes
relates to this
and
particular mission,
50 seconds.
a huge amount of people have put work into it. Obviously, our engines team
Okay,
is
this is
building
the
both the
EMAC
engines for the
escapade
booster, the BE4s,
electro
and the BE3s for the upper stage. We also have a huge amount
magnetometer.
of work by
Yeah,
the
this one is the EMAC
New
one.
Glenn team
The
building this
escapade
vehicle, but
magnetometer,
also New
it
Shepard
says
has
here,
been a
it sits at
pathfinder.
the
So
end of
all our
each
avionics
spacecraft's
fly on
2-meter boom
New
and
Shepard
measure
first so that we can get a sense
measures
of
the
what's going
ambient
on there
magnetic
and get a
field
sense
in
of
the
what
different
it's like to
plasma
have
regions
flight-ready
encountered
hardware,
as
and
they
so
orbit Mars.
takes a
And
whole
yes,
team,
this one really
it's a
provided
very
by the
big
NASA Goddard
cross-functional effort across
Space
Blue.
Flight
You
Center
know, we
with
have
the
more than 10,000 employees here
with
that
the
are really
mission
excited about this moment. I'm one of them.
or
What is your
slash the
message to
project
those who are
leader
going to be watching
J
our webcast and be
J
watching
Epsley here.
NG2 take to the
So
surface?
on the
Well,
range,
I
it
think
actually
everybody
can
will be
measure
a
from
little bit
0
on pins
to
and needles,
2000
I'm sure.
nanotesla.
I would say that
Okay,
this
Tesla,
is
if
a
I remember
culmination of a
correctly,
lot of
is
work
the
from a lot of teams.
measurement of the
It's not the end point of our
of
journey.
the
Obviously, we have a lot more rockets to make and a lot
particle
more customers
electron
to
density,
make
if I
happy
remember
as we move
correctly,
forward.
something like that.
But to the extent we're
Yeah,
successful here,
I think
want
maybe
everybody at Team Blue takes
maybe
a pause,
I'm right here,
smiles a bit,
but if I'm not correct with
celebrates
what I'm saying
because
about the
we have a
Tesla
great achievement
measurement,
for us,
please correct me that
and
one.
we'll take that
Because
deep
at the end of the
breath
day, I study
sort of
computer
embrace the
science, not
moment, and then
not
move on
something
because
a
we have
little
a
bit
lot of customers waiting for us to succeed.
sophisticated. Oh,
And there's nothing that
let's
makes you
try look
happier
at
in business and in your
right.
life when you see the smile on customers' faces.
Did you ever think that you would be doing something like this in your career when you're watching your rockets launch? No?
No, not in a million years.
No,
I
it's
was
not
very happy
there.
making
Not even that.
Fire TVs and Echoes, but
Let's
it is a
learn.
boyhood dream, and so to be able to have
Yeah,
it, I kind of pinch
unit of
myself every day
measurement.
and just
So,
amazed that I get to wake up and help this and lead this amazing.
oh, okay. It's
incredible
magnetic flux
technology like
density.
New Glenn.
Okay, it's magnetic flux density measurement. Okay, so yeah, I'm a little bit wrong there.
What is your first memory?
And the accuracy it can calculate up around 0.5 nanoteslas and 20 degrees for the what is it? For the B, more than 1 nanotesla. Okay, this one I'm not understanding a little bit. Maybe someone can enlighten about this one. Okay.
And we're so grateful to have
Okay,
you
so this one run the ESA, the escapade electrostatic analyzers here. That's why it's called like this.
Obviously, so great to get to talk to Dave,
And
especially
yeah,
when we're
just like
coming
I
on
said, it actually
into this
consists of two
historic
sensors:
moment.
the
But like he said, no
eye
matter what happens today, we have lots of hardware
measures
behind
the
us already in the works.
suprathermal
And it's
ion
a great
flows,
day
and
for
also the
Origin,
E
and we're so proud of everyone
basically
who's been a part
measures
of Team Blue up until
suprathermal
this point.
electrons
Absolutely,
and
and you can actually see the
magnetic
difference even
topology.
between
So
now, you know,
you can see
today and Sunday.
for
They're
the
getting ready to
suprathermal
work
ions
on,
version,
looks
this
like this
one
one is going to be the next
this one
four. We've
actually
got another
handles
four,
by
we've
the
got another
our
raft over
Levy here.
So we've got a lot of rockets that
The
are coming
you
down
can
the
say the
line.
project leader here.
But we're
The
feeling
suprathermal
pretty
ions
good about,
lit
I
by
mean,
the
okay, cautiously optimistic. We know how
by
difficult
the
this is.
university itself.
I'm going to
One
lose
of
my
the
mind
key
if we
people
land
is
this
our
booster today.
Levy,
But as
okay,
we mentioned, we've got other
or
hardware
Livy,
coming
I don't know.
down the line.
I don't know how to
Yeah,
pronounce
and
it
landing the
correctly, so
booster, it's
sorry.
no easy undertaking.
So
Now,
the
our
energy
team,
here,
including
it
myself,
will measure
recently had the
around
opportunity
0.5
to spend a day at sea with our Jacqueline crew and learn
electron
more about the
volt
operation of
up
landing
until the
and securing the booster. Our
30
live view of
kilo
Jacqueline
electron
right
volt here,
there.
around
This
the
is an operation
70%
and a moment
delta
that will change the course of Blue Origin history. Check it out.
E/E like that. Yeah. So I'm not sure what E/E actually stands for. Maybe also another electron by delta electron by electron slash electron. I think maybe this is what actually stands for, but please correct me if I'm wrong here. Okay, and the angles itself, it says it can go around 2.8 pi's here, or around 23 degrees by 23 degrees. Pi, it's coming back again. And the mass itself, the mass, it can be slightly lower or around 4, or it can be slightly more or around 16. Okay, mass. And also the suprathermal electrons here you go. Okay, this one the suprathermal electrons also handled by the university itself, but the key lead people here, the mission, the project leader itself, led by the Whittle say here. Okay, the energy here almost similar except to this one. It can actually measure around 10 electron volt up until the 10 kilo electron volt, around 70% delta E/E, or maybe delta electron slash electron. So correct me if I'm wrong on the definition there. And also the pitch angle distributions will be around 20 until 160 degrees, which will be 23 degrees, which will be around 23 degrees by 23 degrees. You want me to come back again with the angle 2.8 pi? Pretty interesting. And also the ELP, the ESCAPADE Langmuir probe here. Oh, and here is the Langmuir probe here, the thermal plasma. The arrow here, this one, the project lead is the Barjatia, yeah, Barjatia. If I mispronounce your name a little bit, sorry, but look at the name. It's like the Indonesian name here. I mean, if you are really that Indonesian, yeah, well, fellow, so it's Asian. And the ranges itself, it can actually measure from 50 to 200,000. 200. How to actually I pronounce it? I really try to remember this one.
Why it's so difficult to bring
how do I pronounce it properly?
Well, let me just start with the basics. You have a 200-foot tall tower that has just
it can actually the ranges itself, it can actually accurately measure around 50% accuracy from 50 to 200,000
and then the landing pad, as you see, is even smaller than that.
Cubic centimeter, or I don't know, maybe
the landing pad that you see there, the circle is the same diameter
negative
as the
cubic
landing
centimeters.
pad for
I don't know which one,
so, to give you a sense,
but let's just assume it's cubic centimeters here for the easier one. This one FPP, PLP, and also MNLP. You can see there. Yeah. So I guess that's all a little bit mouthful here and there.
and we do have throttling capability on the first stage.
And let's see on the science goals objectives.
It
Oh,
was
no, no.
full of fuel on
Not
the way
science
up. When
goal.
it comes down, it's
I think
essentially
for ESCAPADE
an
or
empty
mission
fuel
design.
tank. So while it
Yeah,
is
so
heavy, it's all
right now
those
we are
those
at T minus
BE-4
5
engines, and the second engine
minutes
is the one that's
and
gonna be
3
doing all
seconds.
the hard
Okay.
work,
So
as it
here we
comes in
go.
just in the last seconds there.
Okay, so this is the
You don't
mission
need as much
itself,
power. We can pull back
mission
on
timeline from the
power
launch.
for a nice soft landing.
Okay.
And when we do, it will be
So
an
launch and
extraordinary
green,
day.
and also
We've talked about
liberation
it. This
of
is
orbit staging
just
would be
the beginning. It
occurring
really is. We will bring this
from
rocket back.
this
We'll
2025
refurbish it. We'll examine
until
it.
almost
We've got
the
all
end
sorts
of
of
the
thoughts on what we're going to
2026.
need to do to refurbish the
Okay,
vehicle.
the
But our whole game
2025
plan, launch,
perihelion
run,
will
repeat, is to
be
be able to flip this
0.99
rocket around and fly it
light
again very shortly here. I
light
should say with New
years.
Shepard,
Oh, no, no,
we
no.
landed the
Light,
first time in November of
not light years.
2015.
It's more like
Here we are 10
astronomical
years
unit
later.
there,
Well, 10 years later, yeah.
something
but it only
like
took
that.
us about
Okay,
2 months
and then
to put around the first
2026
rocket that had
in the
ever gone to
middle
space
would
and
be
back. So we've
aphelion
got kind
will
of
be
same time
1.02
scales that we're
AU,
thinking
and the
here. It's not
perihelion
gonna,
still the same
we want to go fast on
0.99
this.
And if you're
AU,
taking a look at
and
your
then
screen,
the
you see New Glenn on the
Mars
pad. And
injection will
on the
be
upper right-hand
on
corner, you
7
see L minus 4 minutes and
both
about
of
6
7
seconds. That's going to
November
change to a T minus any moment. And that
2026
is
and
really
9
when
November
vehicle itself
2026
is
respectively
starting
for
to
the
run
blue and
on
gold,
its own.
and then
Going to start being
later
able
will
to
be
hear our mission ops
interplanetary
more.
cruise at in 2027. Okay, time interval T minus 3 minutes and 45 seconds. Okay,
Terminal count system is active.
and after that Mars arrival will
From
be
here on out,
around
the vehicle is running fully autonomously
7
on software.
7 September 2027 and also 9 September 2027, both respectively for the gold and blue here, the Mars orbital injection. Okay, check out. Okay, magic charge initiated. Okay, and after that will be the lower orbit planetary phasing, whatever. Perihelion will be around 1.38 AU astronomical unit on 11 February 2028. Orbit reduction will happen around 27 September. 27 September until 12 December 2027. Okay, after that planetary phasing, 5 March until 6 April 2028. Okay, T minus 2 minutes and 46 seconds. Okay, solar conjunction, TSF, 15 April until 14 June 2028. Transition to science, TSF, start science, 15 January 2028, and then science campaign A start, and then orbit adjustment around 15 December 2028, and then begin the science campaign B until 2029, which on 19 February 2029 will be aphelion 1.67 AU, and Mars to Earth's AU will be less than 1 AU. Okay, and after that it will be the end of primary science around 15 May 2029, and then close out. And then basically this is up to NASA and the budget, if they can able to continue extend the mission itself. So that's it, and I'm not going to waste too much time. Okay, I mean today I actually spent a lot of time talking about the spacecraft itself rather than rocket, but I can give a little bit of overview on the first stage. Okay, in between before the interstage, the first stage would be the metalogs, which propellant combination, liquid oxygen as the oxidizer, while the liquid methane as the fuel itself. Yeah, as the fuel itself. That one powered by the 7 blue BE4 rocket engines there. You can see 7 BE4. Okay, and this one they use liquid methane because it's more denser than the liquid hydrogen, maybe slightly imperfect, slightly, how do I say, imprecise compared to the liquid hydrogen, but however super powerful if you try to launch it on Earth. And technically you can still use it as the upper stage too, because it's pretty good. T minus 40 seconds, and then the second stage you can see second stage after the interstage would be the hydrolox propellant. Okay, the liquid oxygen still the same as on the oxidizer, while the liquid hydrogen will be the fuel itself, which powers by only single BE3U engines derived from the BE3PM rocket engines from the New Shepard. Okay, let's go. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and engine ignition. BE7, BE4, all 7 rocket engines ignition, and we have liftoff. We have liftoff and liftoff from the mission. We have liftoff, and here we go. Let's go. And the tracking camera is tracking on the first stage, and let's go. At T plus 25 seconds, the launch is pretty good. We have liftoff from the Canaveral Space Force Station. We have liftoff from the launch complex 36 or 26. We have liftoff at T plus 44 seconds. Okay, and looks pretty good. Yes, yes, so pretty good. Yes. T plus 1 minute. Okay, ready for the max Q. Okay, by now should ready for the max Q. Getting ready. Okay, and then around this max Q and before the max Q. Okay, Mach 1 supersonic, getting ready for the already breaking the sound barrier. Okay, max Q has already been confirmed. Max Q, maximum aerodynamic pressure, fully exerted on the launch vehicle according to the velocity and also the launch vehicle itself. And you can see there's a little bit of the atmospheric water vapor. That's basically one of the good sign. It's already passing to the max Q, and you need to know that by the time before it reaches max Q, and even before it reaches Mach 1, the supersonic the sound barrier there, supersonic there, the rocket engines usually would be tuned down to 60, around 60% of thrust. Sometimes it can be throttled down, if I remember, for the specific specs up until 40%. Okay, it can go up until the 40% of throttling before it goes backs out once it already reaches the max Q. Okay, the maximum aerodynamic pressure. Yeah. Fully exert of the launch vehicle, because you need to remember, if they just full pedal even to the max Q, it might potentially break the rockets and even the payload itself. Okay, and it's not going to be good for the mission. So that's that. And getting ready for the second stage ignition, and after that I will switch to the partial screen view so you can see the indicator. Alright. Okay, Biko. Oh, Biko. We have main engine cut off. Okay, and we have second stage separation. Getting ready. Interstage separation. Okay, and then ignition of the second stage. Oh yeah. So yeah, let's go. Whoa. This is unbelievable. Okay, so this is the view. You can see. Whoa. So unbelievable. Oh my goodness. Okay, and now it will. Okay, we have payload fairing jettison. You can see fairing separation there. You can see. Whoa, it's crazy. Whoa.
And you saw the spectacular view down from our GS2.
Whoa. Okay, you can see. Okay, we are in T plus 4 minutes and 30 seconds into the mission itself, And yeah, so looking the mission is pretty good there.
When we're expecting the first stage to touch down on Jacqueline.
All right, so looking pretty good. Okay, and for the new and existing viewers, hello and welcome, and thank you for choosing my channel, and thank you for choosing Suguwa as your channel to view for these launches. And T plus 5 minutes. Okay.
At 2.8 kilometers per second. Trajectory continues.
Okay, so let's insert here from the
right down the middle of the range track. Engine operating parameters
okay.
to look good.
320 kilometers downrange, around 88, if I remember, 88 kilometers of altitude on for the first stage booster. Yeah, because I'm trying to use only the metric system. It can be a little bit confusing here and there. Okay, and the missions looks pretty good here. Yeah, so looks like we have liftoff around yeah, we have liftoff there almost 6 minutes ago. Yeah, so here we go.
Good data coming down from both GS1 and GS2.
Okay, T plus 6 minutes into the flight.
The 3U engines look good.
Ooh. I mean, seriously, I'm actually pretty hyped to see these launches.
That's an important one.
And let's hope for the best. The launch looks pretty good here. So
going to relight the BE4 engines for the re-entry burn.
On GS1.
Okay, so the first stage booster by now already going back to the Earth, already passed back down from the Karman line.
Miles offshore, waiting for the first time to land. Blue Origin's
yeah, and hope for the best. We are going to see the first stage booster there. Okay, hope for the best. Let's go. Let's get ready to light it, and let's see if Blue Origin will become the second company to. Oh, you can see there. There's three out of 7 BE4 engine has already ignited for the booster re-entry burn. Let's see.
No matter what happens next, we have had
I mean,
a good day. This is further than we waited on NG-1.
You can say it's pretty almost identical to the SpaceX.
Continue to see good data from GS1.
Written. It's also similar to the SpaceX method of the re-entry burn, so it's not. It's not an alien procedure here. So you can see. Whoa, this one is from the tracking camera there. So thank you, tracking camera, for keeping tracking this. Thank you, cameraman. It's not pretty easy to shot this, you know, especially from what I heard for the NASA spaceflight stuff regarding the Vulcan launch previously, the USSF, something like that. Yeah, that one is not really easy to track down, even by the volunteer themselves at the NASA spaceflight. Yeah. Okay, and get ready already on the airplane altitude. Get ready for the first stage landing. Let's attempt. Let's go. If this is successful, Blue Origin will become the second space company that successfully landed their orbital class booster, first stage booster to the landing zone. In this case, to the drone ship Jacqueline. Okay, and the first 3 sets should have already start burn. Okay, now on the cloud itself. Okay, here we go. Hope for the best. For the best. Oh. Here we go. Attempted. T plus 9 minutes. Oh, it's just overshot. I think so, overshot. Oh, and it's successful. Blue Origin now in the record for the second time in the history of the orbital space launches. They finally completed it. They finally successfully landed the orbital rocket class first stage booster. Now they officially become the second space company after SpaceX. They finally did it. Almost 10 years later from the SpaceX. They did it. Congratulations to the Blue Origin. They did it. They did it 10 years later. They did it. Second attempt of landing. They did it. It's unbelievable. It's unbelievable. We see the history right now. We witness the history. Oh man. We see the history. Unbelievable. Unbelievable. Huh. Yes. Unbelievable. Yeah, and also Taran Zero. Yeah. Wow. Yeah, from the comment. Yeah. Whoa. And yeah too. Unbelievable. Unbelievable. It happens. Blue Origin successfully become the second space company in history to land their orbital capable first stage booster. They did it. It's unbelievable. Wow, it's unbelievable. They did it, and they did it before the Chinese. Which one? I think either land space, if I remember correctly, or the Tianlong, the pioneer space. Yeah, either these two. Yeah, they actually did it. Ojuku 3 orbital rockets there. Yeah, they actually did it before Chinese able to chase this Blue Origin. So yeah, finally they did it. Unbelievable. That's the history. Unbelievable. Wow. Wow, they did it. Okay, and now we are going to see how from now on how the rest will actually react to this. SpaceX did it for the first time on 22 December 2015. Yeah, on SpaceX did it for the Falcon 9 rocket for the first stage landing booster there on 22 December 2015, and now almost 10 years later on 14 November or 13 November 2025, Blue Origin did it for their orbital class capable rocket there, first stage landing. I mean, if you even see it, it's pretty slower than the SpaceX, but I can say both achievement for SpaceX and Blue Origin, they are equally great actually. Even though the flight is getting routine and whatnot for SpaceX, but it's still an achievement. SpaceX already make it difficult, but Blue Origin, they became the second space company with their orbital class. I mean, before that, they around the same time in 2015 too, if I remember, the November 2015, they actually did it with their New Shepard. Yeah, so you can say that's practically a 10 years gap, a decade gap there between the New Shepard first stage booster landing via orbital, and now the New Glenn orbital first stage booster landing. Wow, it's unbelievable. It's unbelievable. Okay, and by now it's Tico 1, the second engine cut off number 1. Looks like it's happening then. I mean, everyone very ecstatic there. Even myself did. I mean, if you even hear my commentary, my reaction. Oh, and by the way, if you didn't see my avatar move there, it's because suddenly I'm in low light condition, so I've already opened up my USB light here so you can see me. And of course, because I will actually sleep to this stream in excitement here. Oh, it's unbelievable. Unbelievable.
Hey, I'm in charge of next
At this time in flight, CS2 is now 3,020 kilometers down.
Okay, looks like everyone is very excited. Oh. Yeah, but hopefully, so hopefully I'm also able to see the Falcon Heavy launch, because you want to know something? I never streamed Falcon Heavy actually before. So hopefully I can get this same kind of excitement like I'm watching right now, the new Glenn here. And also hopefully I get the same kind of excitement way back when I actually get myself pretty serious into rocketry with the Falcon 9 rockets there, the Falcon 9, the first time orbital class first stage booster landing, you know. Hopefully I can get the same kind of excuse me for that, you know. I hope so. Okay, so this is the mission control center here. It looks like everyone is excited, and basically they're waiting, and they're basically just waiting for the coverage, you know. And yeah, for the view there, oh, it's pretty unbelievable. But by now, it's on the second stage. It should have already been on the orbital. Initial orbital injection. And for the new and existing viewers, hello and welcome, and especially to the Taran Zero, hello. I'm actually pretty happy, and looks like here you can see. Yes, there is a there's a building size rocket landing on a ship. That's incredible. Yes, I actually share the same kind of enthusiasm with you, Turn Zero. Yes, it's really is a building size there. Imagine you try to land a really big building. I don't know how many stories there, but for the reference point, yeah, I think for the reference point, that's basically the almost the half height of the highest story point here. So especially the Paragon building, you know. So that's why I can actually imagine it's basically that half size, but the building size is pretty crazy, you know. It's crazy. It's really that crazy. And yeah, looks like we are now on the second stage coast phase there. You know, the coast phase is pretty much easy. It's in the ballistic phase stage there. It didn't do anything much. The rocket engine didn't ignite, because otherwise, even if you can ignite, it's going to consume too much of the fuel for practically little to no upsides there. So that's why, and also to take to also, how do I say, to also take advantage of the orbital mechanic effect law there. So that's why we are it's in the costing phase of course. Costing phase. The second stage didn't ignite anything. So yeah. Ooh. And T plus 18 minutes and 24 seconds into the flight. Looks like pretty good here. And this is the first stage view there. The second, if I remember, this is the GS1, the serial number production of number 2. So I don't know if they're going to use this back on the third flight, but if they do, that's crazy. But otherwise, I don't expect they will use again for the first stage there. I don't expect they will use the first stage for the third flight. Maybe they will use again for the 4th, 5th, or 6th flight. Or even then, even if it's not use that, this second serial number built there. Maybe they will be only using that for research, you know, just to see what are the improvements they can use here and there. And here, let's listen in what it says here. Okay, so I can
humans actually go to Mars, and that brings us to our future.
I can go a little bit silent here because I'm tired, but I'm very excited at the same time. Remember, I'm actually streaming very early morning here in Borneo. It's now around my local time right now on 14 November at 14 November 2025 at 5:15 a.m. So it's pretty early, mid in the morning here. So I can take a little bit of rest here. So thank you everyone. Maybe I can edit the text a little bit.
Low cost, high risk science and get our taxpayers the best bang for their buck. You can't beat that.
So can you dive in a little more and explain how both commercial and academic partnerships
past 20 minutes
lead to something
into flight,
like
less than 5 minutes remaining in the coast.
The academic environment means you just get to think for a living. You get to think of these ideas, and this is where the theory comes in.
So here we go.
But then the commercial partnerships, these are the experiments.
And we are now
these
seeing
are the people
tank
who make
pressures
it happen.
increasing in preparation for the next burn.
In academia.
Oh.
Yeah, all of our dreams.
Oh, okay.
And NASA then enables that. So you have this
okay, so let me rest a little bit from speaking.
To do incredible and great things at places like Mars.
How long has this project been underway? I mean, when did the first idea for ESCAPADE come about, bringing it to today?
Rob and I started thinking about this mission back in 2016 and
okay,
2017.
so yeah,
and it
thank you so much. Just give me a little bit of time here.
And years of iteration until we found the right partners, we found the right spacecraft, we found the right rocket, and here we are today. So we are coming up on 10 years in the making to make this happen.
So 10 years in the making to get us to the point of launch. And then once it launches, you have another, let's see, we're in 2025, 2026, 2027, 2028, 2029, another 5-ish years of getting the data before you get the data and then processing that.
5 years of science to me sounds like heaven. So I think for some folks waiting is hard, but for the science team, we are ecstatic. We will take every single bit of data that we can get. And again, with working with our partners, being able to get all of that data and enabling this incredible opportunity to explore not just Mars, but actually the entire trajectory there, that's science waiting to happen.
What is your message to all the collaborators who've had hands on ESCAPADE at this moment in time as you're kind of just waiting for it to deploy?
To all of our collaborators,
3 minutes
thank you from the bottom of my heart. We're so excited. We can't wait to work with you, and we're going to totally change how we do things at Mars. As we get ready for launch, my final thoughts are go ESCAPADE, go Blue, and we're so happy to be here.
And we're so grateful to have you on the team.
Thank you.
Thank you so much. Of course, so great to be able to hear from Dr. Shannon Curry. The booster there, though, on the pad. It is a moment we are still kind of taking in and processing. Ariane, you and I...
buzzing.
I'm excited.
Speechless. I am trembling. My jaw is still on the desk here. An incredible day. The star there.
Right.
The second booster of New Glenn. The stars, all more than 10,000 employees here at Blue Origin. If you guys aren't as in shock as I am, this team has done an incredible job.
Absolutely.
In the years, in the months leading up to this, in the minutes. There they are.
There's the team. That's Kent, Washington, our headquarters. Wall-to-wall people, by the way.
To see our launch control recycle like that, to see the team flip around the rocket from a valiant attempt on Sunday, dealing with solar weather that we haven't seen in years. Working closely with our customers, especially with NASA. Thank you for your patience.
And there's Huntsville, Alabama.
Just an incredible, the epitome of teamwork all the way along to this moment to see
never telling the odds.
Under 1 minute
and if you didn't know,
GS2
that is what we have named this booster. It has been 10 years, as you said, Ariane, almost to the day.
Almost to the day.
Since we landed the New Shepard booster, and here we are in this incredible moment. And today, you and I talked about this earlier, today felt like the day. We walked in, and this was it.
It felt right. It felt right. I'll tell you, Tabitha, I was there for the New Shepard's first landing. And it was a much different Blue Origin. We had a couple hundred people. There were about a dozen or so of us off this back wooden porch with the radio, listening to launch control call the shots as we saw the New Shepard rocket come down a couple miles downrange with our
okay,
naked
so
eye,
getting ready for the second engine start, number 2, SES2.
Billow of dust, and we heard touchdown, and it was this same roar.
I'm sort of back again.
Today, as Eddie said,
Getting
it
ready.
feels so similar, but it
Okay.
also feels so different in the sense that getting this
Okay, so
rocket
confirm ignition
to space
on
and
the
to be able to reuse
second
this booster
engine
is
attached
opening
ignition,
a new
SES2
chapter for
already
Blue
confirmed.
Origin. It's opening a new
B3U
chapter
is
for the
fully on
space
the
industry.
operational
It's
side there.
opening a new chapter
And yeah, there's unfortunately there's no
space as whole, as a not just domestically,
so
but internationally.
unfortunately
To have
there's
more rockets
no,
that
how
can
does
be
it,
reusable,
no
to
visual
have competition on the market, to
rocket
bring
onboard
down the
camera
cost
view
of
here, so
accessing space so that our
not much else
customers, whether it's
interesting
NASA,
that I can
whether it's our friends
talk
at
here.
Amazon Kuiper that
But
have signed
yeah, I mean it's
whether
unbelievable.
viasat, we
That's why
want to be able
I,
to share this
I'm
with the
still
world. And as
kind of a bit
founder Jeff Bezos has
speechless
said,
about
there's
this
so many
experience today.
organizations that
I
want to
mean,
go
glad
out
I'm
and
actually
access
experiencing it
space
together with
and
all of you guys out there,
use
and
those
especially
assets. And
not only
he, as an
watching live
investor,
here
he's
and
seen
especially
so
Taran
many
Zero here,
companies that have come
but
to him and
also
said, well,
the
that's
others,
nice,
you
but
know,
all these
others that
organizations
might watch this on
buy
replay.
unless
You
you can have
need to know
reduce the cost
something.
of accessing
You
space.
really
And by
witness the
having
history
another
here.
reusable
Blue Origin
orbital
successfully
rocket
became the
to be
second
able to do that
uh,
is huge.
space
I
company that
cannot
did
wait
this,
to see what this
that did
rocket looks
the
like when we
orbital
bring her back into
orbital
Earth
class
in just a couple of
booster
days,
stage
bring her back
landing
to
after the
our
SpaceX
integration
with
facility
their
and get
Photon
a
9.
look at this beautiful
Yeah,
rocket. What
just 10 years late, but
And
well,
as we take a
still
look
better
at
than nothing.
GS2, right now we are approaching SECO 2.
Okay, getting
which
ready
is
for the
second
SECO 2.
engine cutoff.
Okay, is it confirmed? Velocity here for the... Okay, so
SECO is confirmed. So we have a
okay,
map view on
so
your
now
screen.
SECO 2,
Soon we should be
second
back
engine
able to
cut off number
communicate with our
2.
ground stations, and we
So
would have a
yeah, it's
picture
pretty
for
good.
you. Right now we are
And
under
by
10
now-
minutes until we're able to deploy Escapade. And if we
Okay,
do
and
that,
by
I mean,
now
what a
it
birthday gift
it
to
should
Dr.
be
Nikki
ready to
Fox.
go
Yes.
on the way
And
to
for
the
two-
Lagrange point
So
number
far,
2
I'm
there.
so glad we had a shot of our Huntsville, Alabama
And
team.
remember, it's not only just
They have
NASA Escapade
built
will be here, but
beautiful
also
engines, the 7 V4
attached
engines that performed so wonderfully on the
but
first
attached to the
stage.
payload
And
adapter
now,
will
as
be
we have
the
heard,
viasat
two
in-range.
VE3U
That one will
engines up
demonstrate
in
the space
space
communication,
had two
will become the
clean
space
burns, giving
communication
Escapade satellites a
technology
wonderful ride to where they need
demonstration
to go,
for the NASA
setting them up,
space
on their
whatever
trajectory
it calls,
to make it
but
to Mars.
And you know
but
what?
it really
While
does
we wait
have
for
something to
this
do with the
epic
NASA
moment coming up
to
with
test out
Escapade,
the
let's
space
hand it back
communication
over to Eddie Safer
between
with
the
our
space,
crew here at
ground
Rocket
station and
Park.
whatnot. It's like
Eddie,
try imagine
I
like the
know
PDRS,
the
the
celebrations have
tracking
already
data and
started,
relay
but of course,
system
the
satellite
show is
mission there.
over. We are
But
awaiting the deployment
if
of
it's much more
Escapade.
modernized
How are
and
you
more
feeling? How are
commercial
they feeling?
in comparison
Because
to
everyone I know pretty
government-led
excited about making
initiative back
mission
then.
number 1
So yeah,
check, and mission number 2 coming up.
so yeah.
Tabitha, Ariane, I don't know where to
Okay,
start.
and
First off,
I
there's
don't think
pandemonium
I
here. Just a
really have
feeling
anything too
of
much to
utmost
say, so
pride and gratitude that
I'll
we got to
rest.
witness that.
I will rest
I had
my
to
case a
step
bit
back
here,
because the party is
so I'll just
ongoing. I
open
can
my
see it with my eyes.
text here.
It's just
I just
years
want
of
to
hard work.
rest a little bit more
You know,
than talking.
there
So
was a
thank you
chance,
everyone.
while
Thank you
we
for
were
understanding.
doing the last session, and it was next stop Moon. This is the beginning. Today is day 1. You know, at Blue Origin we say gradatum ferociter. This was a ferocious step.
Yeah.
Oh, I'll chat a little bit. It's the real pronunciation would be gradatum ferociter, if I remember. if my pronunciation is correct.
I know this moment for all of us, and we are here on TV just representing, as you said, the more than 10,000 employees. We get to peek into Huntsville and to Kent and into Van Horn, but everywhere across this country, I think people are celebrating knowing that we've really made this big step that you've mentioned toward making space more accessible. And I know there's future generations watching right now. I know there's people from all around the world, as far as Brazil, watching right now. And those individuals have to know that we are setting up the future. That's the only way I know how to put it. We are setting up the future, and today was a monumental step for that.
Well, you see, future generations. I actually got a photo from my husband who has my babies propped up and watching this. And I'll tell you, my 3-year-old, she doesn't. She just thinks that our rocket launches and lands.
Oh yeah, that's all she's ever known.
That's all she has ever known. So to be able to show her this live, I'm super proud of being part of this team. I always have, and today is an extraordinary highlight. Eddie, you've been here along with me for 11 years. How do you feel?
Well, no, congratulations. I mean, as you were talking about earlier, how we were sitting in the back porch of Mission Control in West Texas 10 years ago, almost to the day, and how far you've come. You know, your girls are looking at you. That's your rocket that landed today. That's all our rockets, but a special congratulations
to you. That's our rocket, that's right.
No, there's so many reflections that, go ahead.
Oh, I was just going to say, you're right. You know, it's our rocket. It's such something that just brings our team together. I know we can't turn the camera around. I can't imagine why. But how are those celebrations still looking? How many people would you imagine are up there with you?
Okay, so looks like that's a payload adapter here, and you can see the left side is the ESCAPADE Blue, and the right side is the gold itself. Okay, and inside the attached there, if I remember the white area there, that one should be the viasat in range there, to demonstrate the space communication. Of course, it's basically like the commercial version of the TRS, the tracking data relay system. Ooh, that looks pretty funky there. Oh, it's the tracking alright. I hope it's alright there. And yeah, and once again, for new and existing viewers here, hello and welcome. You're watching the Blue Origin's New Glenn launch, the NG-2 mission carrying the NASA's ESCAPADE Blue and Gold spacecraft, and also onboarded the payload adapter, the viasat in range itself. And yeah, actually today Blue Origin already made the history as officially became the second space company that actually landed the orbital class rocket first stage booster back to the landing zone, in this case on the Jacqueline Dawn ship. So yeah, I can say it's 10 years late from the SpaceX before. Yeah, the SpaceX, they actually successfully landed their Falcon 9 first stage booster on 22 December 2015, if I remember, landing zone number 1 or 2, if I remember, around the Cape Canaveral area there. And finally, almost 10 years later, on 14 or 13 November 2025, New Glenn did it with their New Glenn rocket itself. The serial number production, of course, it's number 2. So, and I don't know if they're going to use it again for the future flights. But even if they didn't, well, at least they can proudly hold it as their history. And getting ready for the ESCAPADE Blue and Gold separation. Oh, okay. The ESCAPADE Blue has already properly separated. You can see on the left side there, left side of the payload adapter, the first payload has already separated. And getting ready for the second payload there, the ESCAPADE Gold there, and getting ready on the right side there. Let's see.
over 700 miles in space.
Okay, gold has properly separated. You can see the motion there. Congratulations, successful. Nice. Nice. So looks like Blue Origin's gamble on properly launch the orbital payload, especially the NASA and also UC Berkeley's gamble here finally works. They did it. I mean, it's pretty high risk mission, high stake, but successful. Wow. Oh, if I remember correctly, you see there on the right side there, that's basically a robotic yeah.
To be very clear,
Yeah, that one is the automated robotic camera to actually see if the first stage booster is okay or not. So yeah, it's nice.
Making sure that those landing legs are
it's nice.
The seas are nice and calm today. It was a rough ride the last couple
yeah, if I remember, Blue Origin already had such of this practice even back when they actually landed their suborbital rocket class there, you know, the New Shepard. They actually have their own automated robotic prop there too. So yeah, on every landing zone side of them since then.
Of course, that it's essentially neutralized. Make sure the propellants are nice and stable, if not completely purged from the system, as well as have a stable rocket out there. Safety is #1. But Tabitha, we are
okay, so I don't think I have too much to talk here, so let me rest a little bit. Rest a little bit from talking. Yeah. I'll still keep a tap on this.
It has been such an epic day. In about, goodness, couple of minutes here, also that viasat demonstrator will turn on. That's an exciting thing. That's a payload kind of hitching a ride with our friends at NASA. And it's just been so great to work with so many customers and to also show the world that, hey, we're here. We're in the game. We have a reusable booster, and this is just the beginning.
No, and we said it on the last webcast. We've got NASA ESCAPADE, but of course there are other organizations, UC Berkeley, Advanced Space,
rocket labs
that have been part of that mission. But we've also got Viasat being one of the foremost satellite operators in the world. And these organizations took a chance on us.
They did.
We get it. It was a new rocket. It had not flown when we signed with them. This means
yeah, let me talk slightly a bit. The first stage landing leg, it says according to the official website, actually opens up. Actually takes 8 seconds to properly open up. So from retraction to the full deployment. So that's all.
A new chapter has just opened for, as we said, Blue Origin, but also the space industry.
Would you say a new era? Would you say a new era?
It's a new era.
This is it. It's a new era. And as we said, at the T plus about 38-minute mark, which is happening here in the next 20-ish seconds, that's when the Viasat demonstrator should be turning on. But not to worry, if we don't get an immediate signal, that is totally okay, because that just means it's not connecting to the ground system. They wait about another hour and then they try again. So some exciting stuff. And then just to know that we were a part of a payload going to Mars that we're going to be getting data from, that is going to tell us so much more about the Red Planet. For us to send future humans to the Red Planet, how epic is that? Today was the first day in at least a 5-year mission.
Yeah, no, we're going to be soaking this in for another 5 years. The power of this mission. We're gonna feel it. It's not just something that's up and back. I mean, it is something that's up and back. I take that back. Look at that rocket. That rocket is up and back. But the other.
All right, so getting ready. Less than 30 seconds before the Viasat in-range finally technology demonstrator will open up for the space communication testing there. So get ready. Hopefully the signal will properly pick up. Okay, around
the Jacqueline
10
and
seconds
explain
like
the
that.
operations.
Get ready, 10 seconds.
Then they're going to be able to go and secure all of those landing legs. And then once everything is good to go, a crew can come right back on the Jacqueline and get ready to bring it back here.
Because it looks like it's already powered on for the viasat invention technology in the
Viasat has powered on. It has made connection. That's a bonus. That's 3 for 3.
Wow! Actually, it's successful. Viasat invention technology demonstrator. It turns on and instantly connected to the ground station. Looks like the space communication technology demonstrator mission has already begin right now. Nice.
The same diameter
Nice.
the landing zone as New Shepard.
I know.
Nice. Looks like
150 feet wide.
Looks like all of the objectives has already been completed pretty successful, but this the launch, the deployment of the NASA escapade, and the landing, the first stage landing booster already done, and now even the viasat invention space communication technology demonstrator looks like already begun. Yeah, so and it's on the way right now. NASA escapade is on the way to the L2 Lagrange point from between Earth and Sun, and later we'll go to the Mars. And now viasat invention literally on the way right now. They are testing. So yeah, and also speaking about the viasat invention, a bit shameless plug here. I will also going to stream the viasat-3 F2, the flight to launch of the on board the Atlas 551 rocket configuration. I will also going to stream this a few hours later. I think around less than 5 hours from now. So I will also going to stream that, and hopefully that launch also successful, because if that's successful, I guess Viasat have their best day. Probably they will have their double smile if they're successful. So yeah, that's that. And also a little bit briefing for the Viasat flight number Viasat 3 flight number 2 mission. That one is actually originally intended for the if I remember, originally intended for the Asia region, or what, Asia region, or maybe Middle East, something like that. Originally it should be like that, but however, what happened in that on the Viasat 3 flight number 1 mission is that the transponder, especially the antenna, didn't fully properly deploy, and the throughput is basically only 10% of its planned throughput. So in other words, instead of 1 terabits per second of throughput, it's only able to go with 100 gigabits per second throughput. And Viasat, yes, they indeed already got their space insurance around 683 million US dollars. But however, the flight number 1, the Viasat 3 flight number 1 really operational in the orbit, but it will move from the Americas region. It will go to the Asia's region. It will reallocate to the Asia region, while the flight number 2 will be reallocated to from the Middle East to, or EMEA, yeah, the Middle East area to the Americas one, to replace the kinda botched flight 1, the Viasat 3 flight 1 configuration. So that's that. So it will be relocated. The flight 2 will go to the Americas. The flight 1, the original one, will go to the Asia region. And for the Middle East, I guess it's going to be sometimes later. Middle East, Africa, and also European region. That one is going to be reserved for the flight number 3. So yeah, so that's that. And yes, I agree. Today it's a big day for Blue Origin. Really huge huge win here. So yeah, thank you Turn Zero for accompanying me today, because yeah, otherwise who else going to comment? I really appreciate it, and I hope if you can come for the Atlas 551 flight configuration for the Viasat 3 flight 2 Flight 2 launches. I hope you can come. I already said in the timeline. It's going to be, it will be around 4 hours and 40 seconds. No, it's going to be around 4 hours and 40 minutes from now, where I'm going to stream for that. So yeah, that one is the mission patch. The mission patch there, especially the decal itself, it's not really the easiest, not really the easiest for me to actually find it. I mean, sure, Blue Origin already posted, but it's not really high quality. And that's only what I can do. I just only can use their promotional poster, and I just put it on the Luna Peak. Yeah, I actually use the Luna Peak web app there, Luna Peak, and I just set the I'll just use the auto, how is it, auto background removal, just to get the mission patch. So that's why I can include on my thumbnail. So yeah,
building this rocket, testing it, getting it ready for today.
Yeah,
we want to say thank you to you. We also want to say thank you to
you, thank you to me, thank you to everyone. Thank you for watching this historic flight here. It's pretty good. I mean, yeah, especially
this is going to conclude
as someone that actually tuning into space flight mission for like 10 years and probably counting, and probably even a little bit more because I do have a little bit, if I remember before 2015 2014, I do have some kind of hazy memories about whether or not I'm super interested with rocketry. Maybe slightly, but yeah. Yeah. And 20 years and 30 years from now, hopefully I'm still talking about space flight, you know. And yeah, this one is the launch replay. So let's go. Let's watch it. Again, this is the liftoff one. You can see the water sound suppression system already start, and you can see it's looking like a boiling steam water there. And this is the tracking camera on the first stage, especially on the booster. This is a view the bottom of the rocket itself. 7 PE4 engines, and this one is the re-entry. 3 engines open, and then this is 1 engine open, and landing on the Jacqueline landing barge drone ship 1. Okay, this one is basically they just show like, hey, it's us here, like that. And yeah, you can see there's even like slight decal there. It's looking pretty beautiful, blue there with stars and whatnot. Okay, so I guess thank you so much for watching, everyone. Yeah, and I do really hope you guys really enjoy this. Okay, and yeah, before I actually end up this stream, I'm going to give a little bit live chat comment here, just to comment on Terran Zero. So yeah, before we leave here, let me comment using my phone here. So that's why. Yeah, so that's it. I mean, whoa, I didn't know why the viewers actually suddenly spike right now. why suddenly viewers spike to 3? But hello to the new and existing viewers. We just in case you want to know, we actually already just witnessed the launch of the Blue Origin's New Glenn rocket carrying the NASA ESCAPADE Blue and Gold spacecraft, and also onboarded attached to the payload adapter. It's also viasat in range there to demonstrate the communication, basically the commercial version of the TDRS, tracking data and relay system. So yeah, it's also successful, and today is the day also where Blue Origin officially became the second space company to successfully land orbital class first stage booster, successfully going back to the landing zone, in this case in the Jacqueline landing barge drone ship, successfully after the SpaceX, which the first time ever achieved successful by SpaceX is for the Falcon 9 rocket there, landing back to the landing zone number 1 or 2 if I remember correctly. Yeah, for their Falcon 9 rockets launches back on 22 December 2025. So today on 13 or 14 November 2025, 22 December 2015, and now on 10 years later, almost 10 years later, on 14 or 13 November 2025, the history has been made again. And yes, it's so exciting. It's finally successful. And I guess that's it. I don't want to talk too much, but I hope I see you guys there for the launch of the Atlas V 551 rocket configuration that will carry the viasat 3 flight number 2 from the Canaveral from Slick, if I remember, Slick 41 or whatever is it. I don't want to mispronounce it, but that one, why I want to stream it, because you want to know something, it's going to be pretty eventful, because if I remember, it's going to be the last, for me, it's going to be the last true commercial flight outside of the Boeing Starliner and also the Amazon's Kuiper satellite. So at least by me streaming that, I can actually say farewell to that time, you know, because yeah, Atlas 5 era's going to end pretty sooner than later, you know. It's going to be end there, and it's going to be the last time Atlas 5 will go beyond low Earth orbit. After that, we are not going to see that anymore. It's going to be mostly on the low Earth orbit before finally last flight became its retirement flight, you know. So yeah, I mean, at least for beyond the low Earth orbit, I can consider it as the retirement flight beyond low Earth orbit. But for low Earth orbit, it's still ongoing up until 2029 or 2031, something like that. Yeah. So that's that. And thank you so much for watching, everybody, and take care. And you can watch back again on replay. And I don't want to waste too much time because I want to rest too at the same time. So thank you so much, everyone. Thank you for understanding. And this is my sign of trademark. And this is Daniel Suguwa signing out. And thank you so much for watching this historic flight, historic second flight of the Blue Origin's New Glenn rocket here. Thank you. Yeah, and thank you, Terran Zero. Bye bye. Take care. Thank you everyone. Take care. Bye bye. And yeah, there's nothing else to talk here. Okay, and see you on around 4 hours and 30 minutes from now. Okay, thank you so or for around 4 hours and 40 minutes, like that. Yeah, thank you so much. See you there. Bye bye. Okay, let's end this in 3, 2, 1, go.